Okay, this is lesson 3B.4, and we'll be looking at trapezoids. They'll look at two types, and the first part is just kind of looking at any type of trapezoid and telling what these parts are. So trapezoids are a little bit different from the shapes we've been looking at. What you would call like the top and the bottom are called the bases. So they basically just have two bases. So base 1, base 2, base 1, base 2. Okay, and then we have the legs are on the side. And then what are called the base angles. So right there. Right, and you can see on this trapezoid on the right has the diagonals drawn. That is an isosceles trapezoid, which we'll get into here in a minute. So if I refer to the base or the legs or the base angles, just make sure you can flip back at this and realize what we're talking about. All right, so looking at the first here, we have just a trapezoid is not isosceles, which is the more kind of important one. So the first thing that you will need to know is the bases are parallel. Okay, and we're going to mark that on our figure and then write the statement of how we could write that out. So AB parallel to DC, and we would write that like this. So when we get into proofs next week, that's kind of the important part, is you'll be able to write this line from knowing the properties. All right, the second thing is same side consecutive angles are supplementary. Hopefully you remember that means equals 180 degrees. There is not a way to mark that on the figure, but I can write an equation using that. So same side consecutive angles. So I'm going to pick angle A. Well, A is on the left side, so I know the other one that's on the left is D, and they are next to each other, making them consecutive. So if they're supplementary, that means we can add them to equal 180. So like I said, not a way to mark that on the figure, but you can show it as an equation there. The other set would be angle B plus angle C to equal 180. Okay, and to be honest, I made a mistake and was not supposed to have a number 3 on this, so you can just mark that off. So just to note here, there is nothing on these trapezoids that look like this, where they basically looks like nothing's congruent. There is nothing congruent, and there are no right angles. So the only thing you'll be able to use is like supplementary angles. All right, so let's look at solving for one of these. So number 1 says we're looking for K and M. So I'll just start. K would be here. Okay, well, K is supplementary to L. So that means I'll just use K as my variable. So if I did K plus 51 to equal 180, I would subtract 51 from both sides, and K equals 129 degrees. Alright, if I was going to find M now, so right here, M is supplementary to J, so that means M plus 87 equals 180, and I would subtract 87, M equals 93 degrees. right, number 2. So basically the same thing here. So I would like you to take a pause on the video and try to solve this one on your own. Okay, hopefully you're checking your answers. So when I start off, I just started with C. C was supplementary to B. And so I did my equation down here, subtracted 31 to get 149, and then angle D was supplementary to A. And remember to kind of just use like vision common sense here as well. D is an obtuse angle, A is acute, so they're definitely not congruent. So kind of try to use that visual check when you're trying to set these up. All right, 3. So this one is actually turned because you've looked up here on our original. The bases are the parallel parts. So here the bases are kind of turned. So you need to think of it as being, if it were in like its upright position, I'll try to kind of draw it here, it would look somewhat like that. 54 would be down here. AX plus 6 would be up here. So these are same side consecutive angles, meaning I should add them and set them equal to 180. So AX plus 6 plus 54 equals 180. Combine 6 and 54. We don't do the opposite then because they're just on the same side, so I'm just combining like terms. I would subtract 60. So AX equals 120. And if I divide 120 by 8, I get X equals 15. And that is actually all for that one. So we are going to kind of tie back in here with our properties used. So for that, so look back over your property options. That would be our second property for same side. I'm just going to put SS for that. Consecutive angles are supplementary. Okay, 4. So this one is turned the correct way. It's not turned any which way. So we're just going to think, okay, Q and R. So what's the relationship between those two? Well, they're definitely not congruent if you look at that picture, but they are on the same side and they're consecutive. So I know I can set them equal to 180. I'm going to go ahead and write that property first. Okay, I want you to take a pause and just try to set up the equation here. Go ahead and solve if you can. Okay, if you're checking your answer, you could have gotten either of these equations. If you wrote it all out, you would have got the first one. If you combined like when they were over here, like a lot of times we'll do, then you would have got the second one. You should still get to the second one from the first one though. You're just taking a shorter route. Okay, so next we would add 10. So 19x equals 190. Divide by 19. X equals 10. Okay, but we do need to plug into R here as well. So you do 7 parentheses 10 minus 13. So that's 70 minus 13, which will be 57 degrees. And remember, M just means like how many degrees is it? All right, so continuing on to isosceles trapezoids. If you remember, an isosceles triangle has 2 congruent sides. It's the same situation with an isosceles trapezoid, okay? They do have a few similar things to the first, just the normal trapezoids that we looked at, and that would be that the bases are parallel. Okay, so I'm going to go ahead and mark that and write that. So that means AB is parallel to DC. Okay, they still have the same side. Consecutive angles are supplementary or equal 180. So remember, there's not a way to mark that on your picture, but you can write it as an equation. So this A added to its same side angle would be D equals 180, and angle B plus angle C, which is on the same side, equals 180. Okay, so isosceles trapezoids have a lot more for us to work with here. So we have those two properties that we already discussed, but we also have, in addition to the same side being supplementary, the base angles are congruent. Okay, so on that first page, we identified what the base angles were. They're going to be essentially these two on the bottom. All right, so if I were going to mark that, I would put the little swoops on the angles, and I could say angle D is congruent to angle C. All right, and also, since trapezoids have two bases, angle A is congruent to angle B. And again, kind of use a visual check. Well, C wasn't congruent to A, so opposite angles aren't, because C is acute, A is obtuse. So kind of do that visual check to help you. All right, and still looking at angles, opposite angles are supplementary. And the reason for this really is, well, we knew same side were supplementary, so like A plus D was 180. Well, B is congruent to A, so we can kind of just like swap that out in our equation, essentially. So if I were writing an equation with that, I could say angle B plus angle D equals 180. Say and or here. Angle A plus angle C equals 180. And if you remember what I mean by opposite, is like across from. So A is here, across from it's C. Okay, fifth property is the legs are congruent. Okay, and the legs are on the sides. So here and here. And if I were writing that out in a proof or something, I would say that AD is congruent to BC. And our last one, we don't have drawn, so we need to draw this. Hopefully you remember those are called diagonals. The diagonals are congruent. Keep in mind here, they do not bisect like they did on previous quadrilaterals, okay? They're just congruent to each other, nothing else. So I would say AC is congruent to BD. All right, so all 5 through, it says 5 through 7, should be 5 through 8, but are all isosceles trapezoids. So we're going to find the specified measures. And remember, anytime it's saying measure, it's saying it's once the degrees or the number. We did have a few people on the test mark, like, so on this one, for example, they would have said W is congruent to X, which isn't wrong, but they're looking for the number. So in that case, I guess it is wrong. But all right, so angle W we're looking for. If it helps you, then you can look at kind of our figure here and mark what's congruent to start. Like, okay, well, these two are congruent to each other, and these two, and they already marked the legs for us, but so W is congruent to X, so W is 47 degrees. All right, now the other two we don't have yet, Y and Z, but I know that X is supplementary to either of them, really. But so I could say that 47 plus Y equals 180. And I will take 180 minus 47. Y equals 133 degrees. And then, since Z is congruent to Y, we can just copy that one down. Okay. ZWXY is an isosceles trapezoid, so that makes those two legs congruent, makes these two angles congruent, and these two. Just a reminder, we actually don't need that here, but to show you. They give us angle W and angle Y, and those are opposite angles, meaning they are, hopefully you remember, but if you need to take a look, opposite angles are supplementary, so property, the fourth one we listed there. So I'm going to start with that from a property. Okay, so I'm going to go ahead and combine before I write it out. So 10x and 6x is 16x. 5 and negative 1 would be 4, giving us a total of 180. Subtract 4 from 180. Okay, so that's giving me 176. And if I divide 176 by 16, I'll get 11. All right. So they did not give us anything to actually plug in for Z. So I want to think about what can I plug in to that is congruent to Z. Well, Y is congruent to Z. So I'm going to do 6 parentheses 11 minus 1, or 66 minus 1, gives me angle Z to equal 65 degrees. Okay, so on 7 we're looking more at the sides and the legs, the segments of the trapezoid. So we have MP, which is right here, that's 16x minus 13, and then NO, which is 9x plus 8. So those are legs, meaning they are congruent. So I will just set those equal. And I'm just going to space down. Actually, I'll fill in the property first. So those, I knew we could set them equal because they are legs. So you can just say legs are congruent for that property. And then if I were doing the second part of the question, so MO is 12y minus 37, and PN is 5y plus 19. Okay, so diagonals are congruent. So that will be a really similar equation. So I want you to take a minute and just try to solve both of those. So you'll have an x for your first one and a y for your second. Okay, so hopefully you're checking your answer. You should have got x equals 3 and y equals 8. Okay, number 8. STVU is an isosceles trapezoid. So that tells us that our legs are congruent, base angles are congruent, and other set of base angles. Okay, we're looking for S for our final, but we gotta start off and find X. So we have T and V, which are opposite angles, meaning they are supplementary. So I want to combine my X's. It's going to give me 17x, and then negative 25 plus 1 is negative 24. is that equal to 180? If I add 24, I have 204, and divide that by 17, we get x equals 12. Okay, since we are looking for s though, s is, so you want to think about what is s congruent to? Well, we've already marked it's congruent to t, so I can plug 12 into 3 times 12 for x plus 1. So that gives us angle S to equal 37 degrees. Okay, and the last thing we are looking at today is what's called trapezoid mid-segments. And we're just going to write a couple things about them and as well as a little formula. So mid-segments connect the midpoints of each leg. So in this case, E and F are the midpoints, and they bisect each leg, which is already marked over here, but if we were writing that out in a proof, that's going to look like, so if I'm looking at this leg, first of all, it splits AD into two congruent parts, so AE is congruent to ED, and on the other leg, BF is congruent to FC. Okay, and lastly, a mid-segment's length. So if you're trying to find the length, is base 1 plus base 2. It doesn't matter which one you pick for 1 and 2, just add both of them and divide by 2. You can also think of this as just finding the average of the bases. So anytime you find an average, you add them and divide by how many, and there's always going to be 2. So for the example, if we're looking at this picture using the figure to the left, AB is 14, they said, and DC is 26. So how would we find EF? Well, EF would equal, I would do 14 plus 26 divide by 2. If you are typing this in the calculator, make sure you do the top part first or put parentheses around it. Okay, so that's going to give us 40 divided by 2 to give a mid-segment of 20. Okay, so we just had 2 problems that go with mid-segments here. So PQRS is a trapezoid with mid-segment YZ. Find YZ. Alright, so I'm going to use that little formula that we did. So base plus base divided by 2. Okay, well, I know this is a base and this is a base. So that's going to be 38 plus x plus 14 all over 2. Remember to do all of our top part first. Oh, and we do also have YZ here. Sorry. So I'm going to plug that in to the left side. 38 and 14 will combine to be 52. Okay, so that's as much as I can simplify this top part here right now before I continue to solve. So this divided or over 2 here means divide by 2. So to cancel out a number in the denominator, I want to think multiply it in the numerator. So my 2 over 2 would cancel and multiply by 2 on this side. So you're distributing that 2 to that whole left side. So now I have 10x minus 38 equals 52 plus x is what's left on the right side. I would recommend subtracting x, so that's 9x, and adding 38 to 52. To give us 90, divide by 9, so x equals 10. They do want yz, so I do have to plug back in. So I'm going to do 5 parentheses 10 minus 19. So yz equals 31. Okay, and last question. WXYZ is a trapezoid with mid-segment UV. Find UV. So I want you to try to set up this equation. So take a minute here, see if you can set that up. Pause the video if you need. Okay, here's what you should have plugged in. So I labeled the bases and the mid-segment on the figure. That helps you identify what goes where. Now you want to simplify what you have on this right side. So I have the x's and the constants that can go together. So I now have 7x plus 12 over 2. Remember to move the 2 to the other side. We will multiply it and distribute it to everything. Clarification, everything on the left side. Alright, and then from here we would just solve. I would recommend subtracting 7 from 16, give you 9x, and adding 6 to 12 to give you 18. Divide by 9, x would equal 2. And you were trying to find UV. So plug 2 in for x, giving you 13. Okay, that's all for today. Make sure you complete your homework and the homework check that goes with it. Have a good day.